Hi everyone. So in this video, we will be solving one coding question from TCS NQT exam. So this question got asked in TCS NQT 2025 off campus. 2025 off campus. This question got asked. Okay. It was a medium level question. Okay. It was a medium level question. Let's see if you guys can solve this or not. The most important thing is we will be not solving only this question, but we will be understanding one concept because these questions explain one concept and the whole concept will get covered in this video only by this question. Okay, but before this I just want to tell you that we are making a lot of free videos. You can see here it's a free playlist. Okay, we are posting a lot of free videos here. You can access the free playlist, you can learn. We have multiple playlists for TCS, so definitely you can access the playlist in our channel. Okay, and you can learn for free for TCS. Okay, so definitely we are putting a lot of efforts and content, so make sure to like this video because this is also a part of a free content. Okay, also one thing I which want to tell you, if you have your exam either on 10th March, 15th March and whatever it is, okay, there will be a lot of mock test and live test to you to prepare for your exam. Okay, so see, basically what is a live test I want to explain you. So if you will give a live test, in live test, what will happen? Suppose 200 students are giving the live test. You can see your rankings that in these 200 students where you are standing, what score you are getting. Okay, because this is very, very important. Because when you will compete in actual TCS NQT exam as well, you will be seeing other scores, you will be seeing yours score. Okay, so this is very important that you can see your rank, how much you are scoring, and we will be also providing the full length test through which you can practice. Okay, so the link of the mock test will be in the description. Already the live tests are ongoing, so many live tests are ongoing here. Okay, and apart from this you will be getting the coding sheets for practice. In these coding sheets you will be getting questions like TCS language questions, also daily text for practice we are providing. Apart from this you will be getting a lot of practice sets here. It contains more than like 1500 questions you will be getting for practice. Okay, more than 1500 questions you will be getting for practice. Apart from the full length live test we are conducting, which you can attempt, you can see your ranks, and the price is very, very affordable. Only in 300 rupees we are putting it. Also you have 10 days. In 10 days we will be conducting like multiple live tests, multiple mock tests, so you can practice a lot. Okay, so the link will be in the description. Now talking about question. So this is the question. Okay, a data analytics system continuously records the number of transactions processed by a server every minute. Due to fluctuating traffic, the operation teams wants to monitor the minimum load observed or over every consecutive block of k minutes to detect potential performance bottlenecks. You are given an integer array n of size a of size n, where a of I represent the number of transaction processed in the ith minute. A fixed integer k represents the size of the observation window. For every contiguous subarray window of size k, determine the minimum number of transactions recorded within that window. Okay, so basically it's a sliding window. It's a sliding window minimum question. Sliding window minimum. Okay, they are trying to ask this, that we will be given with a size of k, the window size, and we need to find out the minimum element from that window. Okay, so this is the question which basically they wanted to ask. We will be understanding the concept of the sliding window as well. So input format you can see here. So let's talk about this test case, and from this test case only we will be understanding this question. So let's start. So see here, the value of n is 8. That means the size of array is 8. Then the given array is 4 to 12, 3, 5, 1. 4 to 12, 3, 5, 1, 6, 7. 6, 7. Okay. This is the array, and the size of window, which is k, is 3. Okay. Now we will talk about this. What is the concept of sliding window? Okay. Sliding window means, see, we are creating, see, from this, let's understand the output. Okay, they are asking the minimum number from the window of size k. So the size is 3. So basically in size of 3 we need to find out the minimum numbers. So first, this is the window like 4 to 12. This is the size 3, you can see here. So the minimum number between these is 2. Then the next window will be Now 4 will be getting eliminated. We have 2, 12 and 3. So the next number again will be 2. Then 2 will be eliminated. The next window is 12, 3 and 5. The minimum number is 3. Then the next window is 3, 5 and 1. The minimum number is 1. Next number is 5, 1, 6. Again the minimum number is 1. Again the window is 1, 6, 7. The minimum number will be 1. So our output should be double two three triple one, right? Double two three triple one. This will be output. Okay. Now see, let's try to figure it out. How can we solve this question using sliding window? Because see, the main problem is if you will be using the brute force, in which suppose you are using a for loop. In that for loop, you are again using a for loop for size k, for size k, and you are comparing the number with each other, and you are trying to get the minimum number. Okay, it will give you, it will give you what? TLE error. So in the TCS itself, it was giving the TLE error. This approach, many candidates used this approach, for loop approach, double for loop approach, but it was giving the TLE error, time limit exceeded. Only 2 to 3 cases were getting passed, but baki ke test cases are not getting passed in this case. Okay. So if there is any optimization problem, then definitely we need to optimize the solution. So that is the optimal solution for this is sliding window. Okay. Now let's understand the concept of sliding window. What is a sliding window? Sliding window concept means we will be creating a window of size k. Here, the size of the window will be 3. Okay. And this window will slide one by one. Okay, one by one. Okay, because definitely the window will go like one by one of the size 3. But what we will store here, what we will store here. Okay, so basically in this window we will be storing the numbers in increasing order, in increasing order of the window. For an example, I am for in just example I am explaining you. Suppose this is 4 to 12. Okay, this is 4 to 12. Okay, so we will be storing 2, 4 and 12 like this in increasing order. Okay. Why we are storing this in increasing order? Because just take an example. Suppose our question says only 4 elements are there, which is 4, 2, 12, and for an example, sorry, it is like 4, 2, 12 and 13, or make it 5. Okay, 4, 5, 12 and 13. Suppose these four numbers are there. Okay, so in these four numbers, suppose we are maintaining the size of window as 3. Okay, and suppose the numbers are like this. Okay, so first window will be our 4, 5 and 12, right, of size 3. Now why we are maintaining this? Suppose if we will move our window forward by one step, then 4 will be removed, right? Now the minimum number will be removed, but for the next window when 13 will be added, the first number which we have in our window can be the minimum number. So we do not need to compute the whole system again, that what is the minimum number. We can directly answer whatever the number is in the front will be our minimum number. That's why we are keeping a window like this in which the minimum number will be in front, so that we don't need to compute again and again like which number will be minimum here in the window. Okay, so that's why we are creating a window like this, so it will decrease the time complexity. This is the basic reason. Now how we will do it, I'll just explain you. Okay, so it is not easy. Now we are understanding the concept of sliding window, and it will help you in each and every question if sliding window get asked in your exam. Okay, so basically this is our array, and sliding window we already got it, like how we will be maintaining the sliding window. Now let's start one by one to the dry run. Okay, now let's talk about the dry run. So in the dry run, see, first of all, we have 4. Whatever the number we will be getting, we will be inserting in our queue. So suppose we are creating one queue. In that queue we will be pushing that number. Okay, so first at the starting our queue is empty, so we don't need to perform any kind of operation here. Now we got 4. So the first step will be insert 4. So whenever we will insert the 4 in the queue, our queue will look like now this 4. Okay. Okay. Now we got 2. Now we got 2. So see, now we have something in our queue. Now we have multiple checks and multiple steps to check it. Okay. We have 2. So now first of all, we will check. Okay. We will check here if this 2 we will be inserting, if it is inserting after the 4 or we should insert before the 4, because if you will see the 2 is lesser than 4 and we need to maintain the sliding window in increasing order. But do we need to maintain this 4 if we have 2, because we already know that this 2 is coming after 4. Okay, the 2 is coming after 4, right? And if a minimum number is coming after the maximum, the bigger one, then definitely for each window, this will be the answer. Okay, if you will suppose in this window, 2 will be the answer. Even if you will take the next window, the 2 will be the answer. Okay, because it is already a smaller number and we only want a smaller number. So we can remove 4, right? We can remove 4. So a condition which we will check, a condition which we will check is, see, if a number is coming and that number is smaller than whatever the number is in our queue at the back, we will start removing it. Okay, you will understand it one by one. So now we have 4, so we will remove it because we got 2. Okay, so our queue will look like now 2. Okay, and we will insert each and every number. Okay, now we get 12. Okay, now we got 12. Okay, if we got 12, okay, if we got 12, now do we need to insert 12? See, if the big number is coming and we have already have a smaller number here, then we will insert it. Then we will insert it, we will not remove it. Okay, because as I explained, when our window will go one step forward, then we will remove the first number. After removing the first number, definitely it can be the second number, which can be the minimum. Okay, for the next window. That's why we will insert here 12. So now our queue will look like 2 and 12. So this is our queue. Okay, now we will check out if our window size is completed. So if you will see here, so this three sizes completed here. Okay, this three sizes completed here. Our window is completed already. Now whatever the number is in the front, we will print here. So 2 will be printed here. Okay, now our window will move forward with 1. Okay, now our window will move forward with 1 if the size of the queue, if the size of the queue is 3. So check here, if the size of the queue is 3, no, it is not 3. Okay, if it is not 3, so it is no need to remove any number and our window will move forward like this. Okay, now the next number is 3, right? In this window, please complete the dry run and this question will be getting clear to you. Now we have 3, this new number is there. Now we will insert 3, right? So we will check here 12. So 12 is there. Now 12 is bigger than 3. So we will remove 12. Okay, we will remove 12. And 2 is smaller than 3. Okay, so 3 can be the second smaller after 2, but 12 cannot be the smaller one, right? So we will insert 3, we will remove 12. So it will look like 2 and 3. Now our queue will look like 2 and 3. Okay, so now see, check here, our queue is looking like 2 and 3. Okay, and we are storing the indexes. Okay, please remember, here I am just showing with the number, we are just storing the indexes here. So the index of the 2 is 1 and the index of the 3 is 3. Okay, so we are storing here the indexes, we are not storing the number, we are storing the indexes here. So it is index 1, it is index 3. I am just showing you here numbers like this to for the better understanding. Okay, now again we have the queue like this, so we will print the front one. So again 2 will be printed. Now again we will check if our window is exceeding the size. So now we are on the index 4. Okay, now we are on the index 4. Okay, and we will check our front index, it is on 1, so we are exceeding the size, so we will remove the first one, so 2 will be removed here. Okay, so 2 will be removed here. Okay, so 2 will be removed from this queue, the front one. Okay, this is removed. Now the next number we have, that is 5. So 3 we already have in queue. Okay, now 5 is bigger than this, so that 5 will also get inserted, so our queue will look like 3 and 5. Okay, now 3 and 5 we got. Now you will be able to get the question. Okay, now we have 3 and 5. Okay, and we are storing the index here. Again, I am telling you, we are storing the index. I am just telling the numbers just because for the better understanding. Okay, so it is 3 third index and it is fourth index. Okay, now we have this like 3 and 5. Okay, so 5 is also inserted. Now we will again print the front one. So front one is 3. So we have already printed 2, then we have printed 2. Now the smaller one is 3 at the front. So 3 will be inserted here. Okay. So our answer till now is 2 to 3. Okay. Now again we will check if our window is complete or not. So the first index is 3 and we are on now this index. Okay. So it is still in the size. So we will not remove this one. Okay. So 3 will be not removed. Okay. Now 3 will be not removed. And 1. Now we have 1. Okay. So 1 is smaller than 5 and 3. So 5 will be removed and 3 will be removed. Our queue will be looking like only 1. Okay. This will be our queue because it is smaller than 3 and 5. Okay. So now only in queue, only 1 will be left. Okay. So after that, only 1 will be left now in this. Now we will print the front element, which is 1 only, so 1 will be getting printed. Okay, and the index of the 1 will be getting stored here. So index of the 1 is 0 1 2 3 4 5. Okay, 5. So fifth index is getting stored. Now next index is 6. So we will check if it is exceeding the size with k. So not exceeding. Again we have 6. We will try to insert the 6. So we will insert 6 here in the queue. So it's 1 and 6. Again the front element is 1. 1 will be getting printed. Again the size is not getting exceeded. So 7. So 7 will getting inserted. So 1, 6 and 7. This will be in the queue. Again, the smaller element is 1. So 1 will be getting inserted here. And this will be our final answer. The loop will be getting ended here. So this will be our final answer. Okay. Now, if you have any kind of confusion, let me give you a smaller view what we are doing. Okay. This was a complete dry run, how everything will be going on. Okay. So this was, I was explaining to you how everything will be there in the solution. Now let's quickly talk about the summary, like what we are doing. Okay, so basically in this sliding window, what we are doing is, okay, what we are doing is, first we are checking if the window size is full, if the window size is full or exceeded. Okay, remove the front element from window. Okay, so suppose our window is like this. Suppose 2 3 4. Okay, so window is full, or our window have the index like first, second index, second is fourth index. Now we are moving toward 5 index. Okay, then we will check here the indexes. Okay, now it is exceeding the size, right? If it is exceeding the size of window like k, then we will be removing the front element, because definitely we are moving forward by one step, right? So we will be removing the first one. So this is our first step. Okay, in summary, that we will be removing the first index if our size is getting exceeded. Okay, this is the first point. After that, what we will be doing? Okay, so first one is first remove first index if the size is increased. Okay, size is exceed. This is the first. Second step, if a smaller number, if a smaller number is coming, remove big numbers from remove big numbers from window. This is the second step which we will be doing, because if there is a bigger number, then we will be removing all the bigger number. Okay. Third, push the current element, whatever the element is, we will be pushing that in our window. Okay. Fourth step, fourth step, print the front element. That way we can give the answer of our sliding window minimum. Okay, let's talk about the code, and now you will be understanding it more. Okay, what we have just discussed. Okay, so let's start. So first of all, we have taken the input of n, the size of array, the k, the size of window. Then we created the vector. We taken the input of the vector, the array. Okay. Then we taken the window, the window size. Okay. After that, we created one DQ. DQ means we can perform the front operation. We can perform the back operation. Okay. So DQ we can perform front operations as well and back operations as well. This is double-ended queue. Okay, that's what we are using. Okay, then the step is we started our loop from 0 to n. Okay, again we are checking if the size is exceeding. Okay, so wherever our index is, okay, wherever our index is, so suppose I minus k. Okay, so dq dot front, whatever I have explained. Suppose we are in the window we are storing the indexes, right? And if the size of first index is equals to I minus k, that means the particular window size. Okay, so suppose we are going we are on fifth index. Okay, so fifth minus the size of k is 3, so 5 minus 3. So window size, if you can see here, is 2. And if the first index of our queue is also 2, that means we are exceeding the size, right? We need to insert a new element, so we will remove the first element from here. Okay, so this is the first step which we are doing. I already talked about it. Okay, if we are exceeding the size, we will remove the first element. Then second step, what we will be doing, we will if we got the number. Okay, so if a dq dot back, okay, what we are checking, we got the new number. Okay, we got the new number, and that new number is smaller than whatever the number is in the queue. So that's what we were doing also in the dry run. If whatever the number we got, like one we got as a new number, or we already have 2 and 3 in our queue and we got 1, then what we will be doing, we will be removing the 3, we will be removing the 2, only 1 will be inserted in the queue, right? So that's what we are doing. So if we got a smaller number, we will be removing all the numbers, okay, which are bigger than it, so we will be doing a while loop. Okay, then we will be inserting that number, whatever the number is, what we will be inserting all the numbers. Okay, then we will be checking if the window is formed. If the window is formed, that means if the I is greater than, if I is greater than k minus 1. Okay, if the window is formed, then we will be printing the queue's first number. So a of dq dot front we will be printing, and this way we will be getting our answer. So this is the simple logic, okay, which we have discussed also in our dry run. You can see the Java code as well. This is the Java code. Okay, it is same. It is same what I have explained. Okay, please check here. Again, same code. Okay, and this is the Python code. Please check here. We are also using the DQ here. Okay, so this will be our Python code. So this is the basic approach for this question. I hope the sliding window concept is clear, like how we use the sliding window thing. Okay, and if it is not much clear, I would suggest you to watch this video till 2 times at least, because this is not an easy concept. When you will practice, you will see the code, you will see the question, then you will get it. Okay, also the link of the mock test and the link of the live test will be in the description, which you can use for your preparation. Thank you so much for watching this video.